Hello everyone and welcome back to the DBMS revision series. आज हम DBMS का एक modern और industry important topic समझेंगे. Specifically, मेरे SPPU MCA 2025 pattern वाले students, ध्यान से सुनना. It's a core exam topic for sure, but you know what? The entire real world basically runs on this stuff too. So grab your notebooks and let's get started.
Let me ask you a very simple question. Have you ever wondered how platforms like Netflix or Instagram survive without crashing when literally millions of users log in at the exact same time every night? Right? I mean, अगर हम कॉलेज का कोई छोटा सा प्रोजेक्ट बनाएं और 50 लोग एक साथ यूज करें तो वो हैंग हो जाता है. So what's their secret? Well, the secret is that they absolutely do not rely on just one single computer. They use what we call a distributed approach.
All right, so here is our roadmap for today's revision session. We're going to cover the introduction and working process, look at some real-world applications, dive deep into the 4 major challenges, weigh the pros and cons, and finally, I'll share my special exam tips along with a super quick revision.
So let's jump straight into section 1. Let's understand the core theory first, and I really want you guys to visualize this in your heads as we go.
Here is your exact textbook exam definition. A distributed database is basically a single logical database that is physically spread out across multiple computers or locations. We call these separate locations nodes, and they are all connected together by a network. So to the user, it feels like they're just talking to one single database, but behind the scenes, the data is actually scattered across servers in completely different cities or even countries.
Now, you might be wondering, why do we even need such a complex system? Why not just buy one massive supercomputer? Well, the main reason is to prevent a single point of failure. Just imagine, मान लो आपका मेन सर्वर मुंबई में है. अगर मुंबई में पावर कट हुआ, तो आपकी ऐप पूरी तरह बंद. But in a distributed system, if the Mumbai server goes down, the Delhi server instantly takes over. The user doesn't even notice a hiccup.
Okay, let's quickly break down how it actually works. Step 1, the user submits a request. Step 2, the system is super smart, right? It routes your query to the nearest possible node to keep things lightning fast. And step 3 is execution. The system decides right then and there whether it can fetch the data locally or if it needs to pull it globally from other nodes. All this heavy lifting just happens magically behind the scenes.
Moving on to section 2. This isn't just syllabus theory. The real dunya actually runs on this tech. Let's look at exactly where it's used.
The apps we literally use every single day are the absolute best examples here. In entertainment, we have Netflix and Instagram. For communication, think of WhatsApp, routing billions of messages seamlessly. For storage, Google Drive and cloud storage use this so your photos aren't just sitting in one vulnerable spot. They're replicated across multiple nodes. And of course, massive financial systems like banking or Amazon e-commerce use this so your shopping cart doesn't just crash during a huge festival sale.
All right, सबसे ध्यान से सुनने वाली बात अब आती है. Section 3. These 4 major challenges of distributed databases are literally the heart of Unit 5. This is exactly what the examiner expects you to know inside out.
The very first challenge is data consistency. Think of it like this. मान लीजिए node A or node B, दोनों के पास exact same data होना चाहिए. If you deposit money at an ATM, which updates node A, and then instantly check your balance on your mobile app, which is reading from node B, well, if the data isn't perfectly consistent yet, you're going to see your old balance and absolutely panic. So showing the exact same data across every single node at the exact same second is a massive challenge. This second challenge is synchronization. Managing time differences between servers sitting in completely different locations is incredibly tricky. Just picture a WhatsApp group where friends from India, the US, and the UK are all messaging at once. Every single person needs to see those messages in the exact right chronological order, regardless of any network delays. Getting all these nodes to synchronize perfectly requires some seriously complex algorithms.
Challenge number 3, security. Look, when data is locked in one single room, keeping it safe is relatively easy. But here, we have 2 completely different levels of threat. At the local node level, hackers might try to target just one specific city server. And then, at the global network level, when your data is literally traveling through cables from one node to another, that's when the risk of it being intercepted or hacked is at its absolute highest.
And our fourth big challenge is network failure. What happens if the servers are actually working perfectly fine, but the internet cables connecting them just completely break? We actually call this a split brain scenario. Node A is alive, node B is alive, but they literally cannot talk to each other. Handling this kind of isolation without corrupting the data is probably the toughest task for any system admin.
Okay, so we've tackled the challenges. Let's move into section 4. From an exam perspective, comparing the pros and cons is always the absolute best way to score high marks.
On one hand, the advantages are huge. You get incredibly high reliability, super fast local access because the data is physically closer to the user, and it's highly scalable. You can just easily add new nodes as you grow. But if we look at the disadvantages, the initial financial setup cost is astronomically high. Maintaining all these multiple servers is super complex, and as we discussed, the security risks definitely go up. It's always this massive trade-off between amazing speed and high cost.
We are in the final stretch now, section 5. Let me tell you exactly how to present this on your exam sheet so the examiner is thoroughly impressed.
From an exam point of view, your structure is everything. Step 1. Always start by writing the exact definition. Step 2. Draw those node block diagrams. Just draw some clouds and squares. Examiners absolutely love diagrams. Step 3. Use bold, clearly underlined headings for those 4 challenges we talked about. And Step 4. Include one real-life app example like banking or Netflix for every single point. Do this or full marks bucket.
Let's do a super fast, quick revision just to lock all this into your brain. 1. The concept is a multi-node database acting as one single system. 2. Key apps are Netflix, Amazon, and banking. 3. The big 4 challenges are consistency, sync, security, and network failure. And 4. The ultimate trade-off is high speed and reliability versus high setup cost. And boom, your Unit 5 core concepts are completely clear.
अगर ये रिवीजन एक्सप्लेनर आपको हेल्पफुल लगा हो तो प्लीज़ लाइक, शेयर और सब्सक्राइब ज़रूर करना. But before you go, I want to leave you with a really thought-provoking question. Given all these massive challenges with consistency and security, do you think all future databases will eventually become 100% decentralized, or will we always need some kind of central authority? सोचना ज़रूर. Best of luck for your exams और मिलते हैं next explainer में.